Hey everyone, Centroid is happy to announce the release of its new Plasma CNC controller. This video is an introduction to both the CNC hardware and software that makes up the Centroid Acorn Plasma CNC controller. At the heart of the Centroid Plasma system is the popular and robust Acorn CNC control board. First released in 2017, the Acorn has proven itself among DIY CNC control builders as well as OEM CNC machine tool manufacturers. The Acorn hardware works in conjunction with Centroid's proven industrial quality CNC 12 software. CNC 12 runs on a Windows 10 or 11 CNC PC and communicates with the Acorn through a reliable Ethernet communications cable. The Made in USA Acorn board can control up to 4 axes of AC servo drives or stepper motor drives. The Acorn has its own built-in motion control CPU for fast, smooth, reliable machine tool motion. The Acorn Plasma CNC controller automatically adjusts the height of the torch in real time to maintain the specified target voltage for the best possible low dross cuts. This little bit of magic is made possible by closing the loop between the torch arc voltage and the Z-axis motor position. While the torch is cutting the material, the arc voltage is constantly being measured in real time, fed back into the Acorn, so that the Acorn can then adjust the height of the torch to maintain the specified target voltage. To measure the arc voltage, Centroid has developed its own torch height controller. This new state-of-the-art THC provides industrial-quality plasma CNC machine performance at a price point within reach of the DIY plasma CNC control builder. The Acorn THC is designed from the ground up to work with the Acorn CNC controller hardware and the Centroid CNC 12 plasma software. This design philosophy has many benefits for both the CNC integrator and the CNC plasma machine operator. Centroid has streamlined the installation and configuration of a plasma CNC control system with reliable parts that are made in USA and designed to work together, all while providing the operator with capable yet user-friendly plasma CNC control software. The Acorn THC consists of 2 printed circuit boards, the TX and the RX boards, which are optically isolated from each other. The TX board connects to the plasma cutter's arc divided voltage output, and while it's not a requirement to use, the TX board also connects to the torch conductive or ohmic touch-off signal. The TX board constantly reads the arc analog divided voltage output, converts it to a digital signal, and then transmits it to the RX board via fiber optic cable. This Centroid fiber optic technology isolates the Acorn CNC controller from any plasma-generated electrical interference. The RX board then, in turn, communicates the arc voltage information to the Acorn CNC controller via a standard serial cable. With only a couple of connections and 2 cables, the Centroid THC is truly plug-and-play with the Acorn CNC controller. After the hardware has been installed, the THC configuration is done completely through software. Let's check it out. From the main menu of the CNC 12 Plasma software, I click on Profile Manager and then the THC configuration menu. You'll see there's just one menu here with all the THC configuration settings in one spot. These values are mostly in the set it and forget it category and are pre-populated with default values. So let's do a quick run through. The first thing I want to do is click on the slider to let CNC 12 know that there actually is a THC installed. Next up is the voltage divide ratio. This is the actual arc voltage divider ratio that you set in the plasma cutter itself. And this setting is here to let CNC 12 know what kind of signal to expect. And here we have the velocity anti-dive ratio. This setting allows you to control when the THC will automatically turn on and off based on machine velocity as a percentage of the programmed feed rate. For example, if the machine tool is cutting a small arc and the velocity of the X and Y axes of the machine drops below 90% of the programmed feed rate, the THC will automatically turn off. Then, when the velocity of the machine goes above 90% of the programmed feed rate, the THC will automatically turn back on. We also have got controls here for anti-dive threshold. This is a percentage of the target voltage to stop the THC from diving down unexpectedly, and the related anti-dive hysteresis. The hysteresis stops any sort of oscillation. Next up is the THC maximum velocity. The default value here is 500 inches a minute. The Acorn THC is very fast and reactive due to the closed-loop technology described earlier in this video. What you want to do here is, if your machine can move 500 inches a minute in the z-axis, the THC can fully make use of the speed of that machine. But if your machine can't move 500 inches a minute, you simply use this parameter to throttle back the maximum rate of the THC to match the machine. Next up is the pierce to cut Z feed rate. This value allows you to control the speed of the move from the pierce height to the cut height to maintain a good arc for your particular machine. And then we have positive and negative travel limits for the THC, where you can limit the maximum movement of the THC itself. Next up is the torch touch-off fast and slow probing rates. These default values of 30 and 15 are very conservative. You'll definitely want to pump those values up to some higher numbers. And last on the list is the plasma dry run selection. You've got 3 different heights that you can select to dry run a part. So over here on the VCP, we've got a great little button here called dry run, which allows you to dry run the part without the torch running. And this selection here is simply asking you at what height, the safe height, pierce height, or cut height, would you like to run the dry run. So that's the Centroid THC configuration menu. When you've got your settings the way you want, all you do is hit done at the bottom of the screen and you're all set. So in addition to the Acorn Plasma CNC controller being user-friendly to configure and install, both the programming and running of the machine is user-friendly as well, with convenient operator controls for efficient workflow. Running of the plasma machine can be done from the Centroid operator control panel, as well as an optional wireless operator control pendant. While it's not required, the operator control panel can be used in conjunction with a touchscreen monitor. When using a touchscreen monitor, you can touch the screen to activate any of the buttons on the operator control panel, or use the mouse to click on any of the buttons. If you don't have a touchscreen and you're using a regular monitor, you can simply use the mouse to click on any of the buttons on the operator control panel to activate them. With the wireless operator control pendant, you can bring the controls to where the work is. The Centroid developed firmware in this Centroid CNC control pendant provides superior CNC performance over other similar pendants on the market. The pendant provides frequently used plasma controls at your fingertips. Common uses of the pendant are jogging the machine around, setting part zeros with and without a laser, controlling the feed rate override of a job and the target voltage override, as well as using the popular Centroid restart feature that enables you to restart a job after an interruption. Running parts with the Centroid is straightforward. There's a built-in plasma profile manager. The profile manager has an extensive library that contains common materials and torch settings. To start a job, you look through the library, find your particular type of material, and then the amp setting, and then the thickness. Click on that, and then the profile manager automatically fills in all the plasma-specific data. This data contained in this library is from the published Hypertherm cut charts. So let's check it out. I'll choose 1/4-inch steel at 65 amps, and you'll see that the profile manager has filled in the Hypertherm cut chart data. It's also interesting to note that you can change any of these values in any particular profile, and you could even change the name of a profile and save it out as a different profile. You can also share any modified or new profiles from one machine to another. Now, a material profile has all the standard cut chart information contained within it. Feed rate, target volts, pierce delay, end delay, pierce height, safe height, THC active delay, and then you can choose which type of THC mode you want to be in. You can disable it, have it be in automatic, or use the Centroid SmartSense. SmartSense will read the actual torch voltage at the cut height during the initial cut, and then use that particular voltage for the rest of the cut. And then we have cut height controls where we can enable or disable the cut height and specify the actual cut height value. Last but not least, at the bottom is a Centroid exclusive, Plasma Smoothing. Plasma Smoothing will smooth out the machine tool motion for better cuts with lower dross. Once you have selected the profile that you want and made any changes if necessary, all you do is hit the Done button to run the job with that particular profile. Let's take a closer look at the Centroid Plasma Operator Control Panel. Starting out with the machine tool jogging controls, which are found here in the upper right. These yellow buttons are what you use to move the machine around. You'll notice that there are dedicated buttons for each axis and direction, so you just push the button to move the machine the way you want to go. The jogging controls operate in 3 distinct modes. We have slow, fast, and incremental. Over here on the left are a group of buttons that you use to quickly set a part 0 location. There's also a laser set XY button, so if you have a crosshair laser installed on your machine tool, you use that button to use the laser to line up where the 0 position is for the job that you want to cut. Moving down right below that, we have the target voltage override controls. These buttons allow me to override the programmed target voltage as a percentage on the fly. This is kind of similar to the feed rate override, which is located here in the lower right, as I can also override the cutting feed rate of the job on the fly as well. Now, right above the feed rate override are a whole bunch of controls related to running a job. I'll start out with the green cycle start button, and then the corresponding red cycle cancel button. There are also a number of very useful features here. I'll go over them very quickly. We have a torch check button, a dry run button, a feed hold button, controls to turn the THC on and off out of auto mode, a rapid override button. We have a button to do a torch touch off. So if you just want to touch off the top of the material, you hit this button right here and it automatically sets the top of the material. We also have manual controls for torch on, torch off, and a momentary test fire button just to clear the torch, say if you had water up in the nozzle there. You just hit that button and it fires the torch. Now moving to the left, we've got several buttons here that are 1 button presses to go to the part 0 position, go to home, reset home, or go to the safe height position. And finally, I saved the best for last. These 3 buttons here are the controls for the Centroid Plasma Restart feature. Restart is used to restart the torch along the part path after an interruption. These 2 buttons here are the restart backward and forward buttons. These buttons allow you to move the torch along the part path so you can choose a good point to restart the torch and finish the job. It's also interesting to note that you can change the Centroid operator control panel from both a functionality and appearance standpoint to suit your particular application or taste. Changing any of the colors, words, fonts, icons, or logos is all done through simple SVG editing that anybody can do. Adding, deleting, or rearranging buttons is also simple to do by editing an easy-to-understand XML file. Modifying a button's action or adding a new functionality is also user programmable. The Acorn controller is compatible with a wide variety of CNC plasma torch mounts and different types of torch touch-off methods. Shown here is a Made in USA 3-sensor CNC torch round mount. This particular mount is equipped with 3 proximity switches. 2 of them are the breakaway signal switches, and the third is the torch touch-off switch. 2-sensor round mounts are also compatible with the Acorn Plasma CNC controller. The one shown here has 2 proximity switches. One is the breakaway, the other is the torch touch-off sensor. Magnetic CNC torch mounts are also compatible. This Made in USA unit is pretty nice. These types of torch mounts add an extra layer of protection to the torch. This is a simple design that has one sensor, a breakaway sensor, that is then wired back into the Acorn CNC controller so that the plasma system knows when the torch has broken away. Magnetic torch holders can be mounted directly to the Z-axis or to a floating head slide. The floating head allows the addition of a torch touch-off switch This switch is sometimes also referred to as a float switch. The various torch touch-off methods and their corresponding switch locations and types are compatible with the Acorn Plasma CNC controller. This means that you can use a conductive or ohmic setup as a standalone method. That would be your sole source for touching off. Or you can use that conductive ohmic setup in conjunction with a float switch that is mounted in a round mount or a sliding head. Or you can use just the float switch and not use ohmic at all. When you use the two in conjunction with the Acorn Plasma CNC controller, it's pretty cool because when the torch is touching off, if you're using ohmic in conjunction with a float switch, if for some reason the ohmic doesn't trigger, the float switch acts as your backup. So if there's heavy rust or oil or wax or paint on the material and the ohmic doesn't trigger, eventually the float switch would trigger, and you can set that up in the Acorn Plasma CNC controller to use the float switch if the ohmic doesn't trigger. So it's kind of like the best of both worlds. It's a pretty slick setup. So there you have it, the Centroid Acorn Plasma CNC control system. Please visit our website and click on the Acorn Plasma link for more information or to purchase directly online.